Okay, so how is everyone today? Good? All right. So today's the 27th. So just reminders. So, you know, under normal circumstances, 150 and 151 would have been due Monday, but because of the box glitch, we're going to turn in, you know, you could have turned it in Monday or now. That's why 150 is there. But 160 and 161 are just due today. As a reminder, this is a quiz week, so next time we meet is quiz 20. So let's write that down. You know, just general stuff is that, so first is that quiz 20 is on Friday. And again, you know, that just so there's no panicking about the name there, that doesn't mean that there was like a quiz 19. Okay, that just means that you know, the meetings that we meet are numbered, and Friday is numbered 20. So fine. Concerning that, the material, or if you like, the new material, is from quiz, you know, quiz 14, not including that stuff, and then up to and including what we're turning in today, WHW 16. So that's the new stuff. And then, you know, quiz 8, 08, and quiz 14 have been returned, so there could be redos from that. There will be some redos. Just a minute, I'm putting new pencil lead in there. So then, you know, redo possibility. Oops, redo. Section from previous quizzes. So this is the first time that's going to happen. Of course, those are quiz 0H and quiz 14. So what that means is, you know, for example, you know, so maybe you didn't do so great. Maybe quiz 08, and then I don't even know if this really was a question, but I'll just write it down like 031. I don't know. I don't know if there really was a question. But what I mean is that if you look at the scan of your quiz 8, then in the top right corner, there'd be a question with that number on it. From quiz 8. And you know, maybe you didn't do so great on it. Maybe you got like 2 out of 10. You know, and that would, you know, would be something like that. Bubble number 2. Okay, then, you know, that means that, you know, you didn't do very good on that exercise. Well, you know, it could be the case that question 031 is going to be available for redo in 2 days, and you know, you've got to be ready for it. Okay, so be ready if 031 is in the redo section. All right. Any question about that? Yes?
Can we write down the things we need to redo and bring it?
Yeah, that it would be fine if you brought, so I'll write that down. So you can bring a small sheet, so not like a big old thing. So bring a small sheet with these numbers. And then you can, while you're writing your name on the front and your ID and what have you, you can copy those to the front page, and then put the little sheet away. So copy to front page. Because who wants to try and memorize some list of numbers? Other questions? All right. Good. So quiz is on Friday, blah, 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 blah. So this is usually the next question that students want to ask, is that when can I come see you? Okay. So then, as a reminder, this is my time here. So of course my office is FA 2.402. Now you need to be careful, because on campus there's three buildings whose name has Founders in it. So like we're in Founders right now, and then just north of here is a building called Founders North, and then just west of here there's a building called Founders Annex. Okay, so then generally the arrangement is kind of like this. That FO looks like this. So this is FO. And we're approximately like right there-ish right now. And then, north of us, it's a building called FN. And then just west of us is a little bitty building called FA. And my office is about right there. So here's the north arrow. But the problem, that's fine and everything as a system of naming, but the problem is that there's a 2.402 in all three of those buildings, and every one of them has a math person in it. So all the time, no one ever comes to my office looking for someone else, because this is like a little building that's easy to overlook entirely. But all the time, folks are going to these two buildings looking for me, and I'm not there. All right. So there's my office, and then my office hours. For today and tomorrow, which is the most meaningful for y'all right now, is that today I'll be in my office 12:15 p.m. to 4 p.m. and then tomorrow from about 10:15 a.m. to 4 p.m. No, that's actually tomorrow, 3 p.m. And I would be happy to see you. But those are the only office hours between now and time to visit me between now and the quiz. Any questions? All right. So last time we were talking about domain and things like that. So last time we had we were sort of the last thing that we wrote in questions was something like therefore the domain is all reals except x is like negative 13 and x is 14. We were writing statements like that. And that's a fine statement as far as it goes, but we want to be able to write that in a nicer way. So we want a nice system / notation to write things like that. All right. So to that end, we're going to talk about something called intervals. Intervals. So an interval is a contiguous subset of the reals. Oh, and it has to be a non-empty contiguous subset of the reals. All right, so fine. Now that word contiguous is not a real common word, and it sounds like another word that actually is kind of common, continuous, but that's not the one I meant. That's not what I meant. So I meant contiguous, and that's what I wrote. So to understand what that means is, so just as an aside, outside of a math class, the most common place I've ever heard it is in the following phrase: the contiguous United States. All right. So then, what does that mean? Yeah.
Basically, the ongoing part of it itself gets the main part.
Okay. So in the specific case of the United States, that is going to be right, but that's not the reason for the word contiguous. So there's 50 states in the Union, right? And 48 of them are called the contiguous states. So which two are left out? Hawaii and Alaska. And now, why are they left out of the phrase contiguous United States? Well, in the end, the word contiguous means touching. So imagine a globe or a map, and imagine looking at Hawaii. Well, is it touching any of the other states? No. And Alaska also has this property, that it's actually not physically touching any of the rest of the United States. So the contiguous United States is the set of all stuff that's touching. To give another example that's gruesome, but gruesome only so it'll help you remember the word, is that the normal physiological state of your body is that it should be contiguous. And if that is ever not the case, then that's like a medical emergency, right? Good. Contiguous. Now, we want to be able to have a nice way to write this down, and we're going to do it by example, and I'm going to have 3 columns, 1, 2, 3 columns, like so. So the left column, we'll call it the algebraic notation, algebraic. Notation. The middle column, plot notation. And the right column, interval notation. So first example. So maybe we're interested in all the points that are between say -3 and 8. So we could write like this. So -3 less or equal to x less or equal to 8. So, you know, that's how you write it algebraically with inequalities. Okay, so can someone give us an x that's in there? 0. 0's in there. All right, can someone give us an x that's not? 9, right? It's too big. And -9, well, that's too small. Okay, so then to draw this in plot notation is drawn like this. So a filled in dot like that, a big filled in dot, and then a horizontal bit and another filled in dot, and -3 and 8, like so. All right, and then we have this yet another way to say the same thing. And when you're writing arithmetic expressions like, you know, 3 plus 5 multiplied by 7 exponent whatever, you can put parentheses wherever you want, and the shape of the parentheses is not significant. You know, like you can write like big ones and little ones and things like that. That's not significant, but in this context it is significant. So I'm writing square parentheses for both of them. And then, you know, just for those of you that like to know the real name for this, they're not called square parentheses, they're called brackets. Okay, fine. Next, I could say, well, all right, that's fine and everything, but actually I didn't want the 8. I wanted all those numbers that you're talking about there, but I actually didn't want the 8. Okay, so then with inequalities, how do I write, yeah, all of that, but I don't want the 8? How do you write it? So this bit will still be the same. Right, so just less than 8, like that. So the only distinction is that instead of writing less or equal, it's just less than. Okay, then to draw it, so this bit will still be the same. So -3. Now coming up to 8, but now I need to draw something that signifies that we're going to have all the points up to, but actually not including 8. So how do we signify that? Open circle, right? So like this. So that's how it's visually signified. And then similarly, we want to be able to write this. So this is still the same, so -3, like so. And this is still 8 here. But then how do we signify that we're not going to have the 8? Yeah, a parentheses, a round one. Okay, so then now I can say the same game and say, oh, actually, you know what, I didn't mean it, I didn't want the 8. What I actually meant is I do want the 8, but I didn't want the -3. Okay, so then now exactly the same thing, except we're going to make those changes to the -3. All right, so the -3 less than x less or equal 8, and then open at -3, closed at 8, open at -3, closed at 8, and then I could say, oh yeah, now I actually thought about it. Yeah, I want all those points, but I don't want either one of the end points. I don't want either one. So now what do we do? Is it obvious? Okay, so I'll just do that one quick. So now, you know, -3 less than x less than 8. So both of them are less than. Neither one is less or equal. Now for these, both of these are open. And for this, both of these are parentheses. Any question about this? Now, these, you know, of course, there's nothing special about -3 and 8. I could have chosen other numbers. But observe that it only makes sense if that one is less or equal to that one. Right? It wouldn't make any sense to say 8 there and -3 there. That doesn't make any sense. All of these intervals, all of these examples, These are called finite intervals. They're called finite intervals because, if we got out a ruler, and if this was, say, in whatever you like, centimeters, inches, miles, whatever, we could get out the ruler and say, oh yeah, the length of this is 11. That's how long it is. It's not an infinite length. Okay, so then if there's finite intervals, then well, evidently there's going to be infinite ones too. So as a brief pause, I'll say recall that the symbols negative infinity and positive infinity have the following properties. So first, negative infinity and positive infinity are not real numbers. So like, you could name whatever number you care to name. 3 is a real number. Pi is a real number. Negative pi is a real number. Those are all real numbers, but infinity is not a real number. It's not. Second is that infinity, just the bare symbol without a plus or a minus in front of it, and positive infinity are the same thing. And whether or not you write the positive, because those are the same, whether or not you write the positive is sort of up to you. And the only time I really write the positive is if I really want to emphasize something. So like when I just write 7, then that means positive 7. And when I mean negative 7, I've got to write the negative. But if I really wanted to emphasize the fact that it was positive 7, then I could write plus 7. Same deal with these. C is that negative infinity is less than smaller. Smaller than every real. To make that sound right in my head, I need to put a smaller than in there. Every real. Which is to say, x is greater than negative infinity. So that's going to be true. And a similar thing and understand what I mean by that is that positive infinity is not a real. What it represents a thing that's bigger than every real. So it doesn't matter how big of a number you imagine, like 7, infinity is bigger than 7. It's bigger than 7 million. It's bigger than any number that you can name. So to that end, we can, with that reminder there, I could say, well, what if we want, say, all the x's that are greater than or equal to 8. So notice that this is different in the sense that these first 4, these finite intervals, it was always x between 2 things. So now it's just x greater than or equal to 8. So how do we draw it? Well, here at 8, we'll have a filled-in circle. It's included. And then we're saying that we're talking about everything that's 8 or bigger. So, I'll draw this bit, and then to signify that it never stops, I'll draw an arrow. Okay, so 8 or more. Fine. Then, as for the interval notation, we're going to draw it like this. So starting at 8 and including 8, and then what do we write? Infinite. And then what do I write right here? Parentheses, right? So that one. Okay. Whenever I'm doing these, I always make sure that at least one of the times I use an 8 because I just think that looks funny. Because, you know, it's like just rotated. That's fine. But I do want to note that a very common error here is that that it is never. You never write 8 to infinity like this. So that's not right. Why is that not right? Right. So if this could mean anything, I suppose it would mean the set of all real numbers 8 or greater, and also including the symbol infinity. But infinity is not a real number, so it doesn't make any sense to include it in an interval. It doesn't belong in there. In the same kind of way that you know, if you were to go to the grocery store, and you know, among the items you pick up is like a bag of oranges, and then you get home because you just really want an orange, and you look in there and there's like a potato in there. But it doesn't belong there, right? It doesn't belong in there, and the same thing here. This infinite does not belong in there because an interval is a subset of the reals. It's not in there. Fine. So now all of these finite intervals, we wrote it as x between two things. And you might want to, in some instances, write an inequality where the x is between two things. And the way you could do that is you could say negative infinite less than x less or equal 8. Sorry, what am I saying? That doesn't make any sense. Rather, 8. My goodness, I'm having trouble here. 8 less or equal x less than infinity. Better. Any questions about it? Good. Then you know, you could imagine, well, what if I say I want all of the x's that are less or equal to 8? So it looks really quite similar to the one I just asked, except now the alligator's eating the other way, right? So this one, that one right there was like this, right? And then this one's the other way. So then how do I draw this? So now the 8 will be over here on the right. And then now we want to go to the left, right? All the way to the left. And so the way you signify that is with an arrow. Okay, and then for this one, like so, negative infinity to 8. Any question about this? Finally, to give a final example, I could say, well, this one was all the stuff between 3 and 8, but not including, negative 3 and 8, but not including negative 3 or 8. Don't include either one. This one was stuff that's 8 or bigger, and this was 8 or smaller. And then suppose I say, well, I just want it all. I don't. Nothing's going to be left out. I want it all. Okay, then the way you draw it is, you're going to have this horizontal bar, and because we want everything, what do I put right there? An arrow. Right? We're going all the way to the left. And what about here? Arrow, because we're going to go all the way that way. Okay, fine. And then what do I write for that one? Yeah, negative infinite to infinite. Like that. Okay, and then what do I write for inequalities? Gesundheit. So it'll be negative infinite less than x less than infinite. And of course this, well, that's a synonym for the reals, so here's another way to write it. Same thing. Any question about it? This notation? So these are called finite intervals. and these infinite intervals because they have an infinite length. All right. So this is okay. Fine. So what we want to be able to do now is we want to talk about the algebra algebraic operations. Algebraic operations on sets. Okay, so what I mean here is that typically, you know, in this class, if I just say algebraic operations and then I don't go on to say on sets, if I just say algebraic operations, then what's meant is we're talking about algebraic operations on real numbers. So like, you know, an example would be something like if I say 7's a real number, what's its negation? -7. Okay, notably, I give you a number, 7, and I say, what's its negation? And the answer in the end is another real number. Okay, so another example of an algebraic operation would be, suppose I give you two numbers, so 3 and 5. Now add them. What do you get? 8. It's another real number, right? So you take these two real numbers and you combine them with an add, and then now you've got another real number. So what I'm saying is that we're going to do something like that with sets. Is we're going to say something like, here's a set, and we're going to say something that is like negation. So I'm going to say like, here's a set, and then you know, what's its opposite? And then another thing we're going to say is you know, here are two sets. Now combine them in this way to get another set. All right. So here it is. Let X be the universal set and let A and B be subsets of X. Okay, and the way, when you all talk about it in grade school, the way it's usually visualized is something like this. So you got like a big rectangle here, and then I'll write X. And what I mean by that is that, you know, where this idea is considered, we're only talking about points that are in the rectangle. So like, that's a point that we're talking about. That's not a point we're talking about. And then set A, I'll denote as just a big circle in here. So here's set A. And then so, you know, concerning set A, that's a point that's in set A, and that's a point that's not in set A, and you know, that it doesn't even make sense to talk about that point. It's outside of the universe. All right, then we have set B. Fine, and so similar things about B, and so then now I could, you know, ask you some questions and say like, you know, looking at what I drew or what you wrote or whatever, can you find a point that happens to be in set A but not in set B? For example, can you find a point that's in not in either set A or set B? It's in neither one. And that one. Points that happen to be in both set A and set B. Yeah. Okay. So that's what we're talking about here. So the first definition is this. This is called the complement of set A. Now, in English, there's two homophones. Homophone? Is that the right word? Yeah, same sound. There's complement, which is what I've written here, and complement. So we're not trying to figure out something nice to say to set A, right? That's not what we're saying. Rather, complement here means the opposite. Okay, so it is denoted as A with superscript C. so and pronounced out loud as a complement. And it is the set of all points which are not in set A. So if I just make a little bitty version of that and say that the shaded in bit is set A, so if that's set A, then and here's sort of the skeleton, here's the universe, and then that, you know, is where set A would be. Then you know, please shade in a complement. So what will it look like?
Everything in top circle.
Right. You know, so if you were to take these two bits, just take that shaded bit and that shaded bit, then you could like join them together, and that'd be everything. That'd be the whole universe. All right. Now, to bring it back to what we were talking about before, I could write something like this. So, for example, 8 to infinity, that interval. Then I'll draw the whole universe, which is you know, all the reals. And then what I want to do is I'm going to use red. Well, no, I won't use red. I'll just graphite. I want to color in all that is signified by that. So this is like the whole universe, and I want to shade in just that stuff. So, you know, if that right there is 8, if that's 8, then that interval, the way to do it is I'll make a big, you know, filled in dot there. So we're including that, and then I'll shade in all of this. Right? So that's 8 to infinity. Fine. But then what about, what is 8 to infinity complement? So again, I'll draw a number line here and say that, you know, there's 8. Okay, and then I'll give you a moment to shade in the right bit there. Okay, so then, you know, what we want to do is basically shade in everything that is not shaded in here, right? So, you know, do I need to shade that point? No. Do I need to shade that one? Yeah. So this is going to have to be shaded like that. Okay, and you know, for that matter, all of this too. And all of this. But what about when I get to 8?
Just a circle.
Just an open circle, right? To signify that it's not included, because it was included over there. So can you see it? So what you know, you can kind of think of it like, you know, like the whole universe is the real numbers, and here's a set, and that's its complement. And if we were to shade all the stuff, in that one and in that one, that'd be everything. Okay. Good. Now, neatly, this itself is an interval, isn't it? So that's an interval, and the complement of that interval is also an interval. So what is it written as an interval?
Negative infinity to 8, open bracket.
Open.
Parentheses.
Okay, any question about it? So what I'm telling you is that this is, where sets are concerned, this is just like me asking, what's the negation of -9? +9. What's the complement of this set? That set. Okay, fine. Then we've got another one, another thing. We've got the union of set A and set B. So this is denoted as A, and then this symbol, which kind of looks like a U, B. And notably, it's the union symbol, not letter U with a foot. I won't take off points if you write a foot, but it just kind of looks silly. You know, and it kind of looks like you know, when you know, kids are learning how to write first, and you know, they'll write letters backwards. You know, it's kind of what it looks like. So that symbol is that. It's not a letter U. What this is this is the set of all points in set A or set B. Okay, now this word "or" means something in math that doesn't usually, it's not the same thing that it means out on the street. So here's an example. You know, so when math folks go to a restaurant and the waits, you know, the meal's about over and the wait staff says, you know, would you like cake or ice cream? The math folks say, yes. Of course, that's not at all what was meant, right? What was meant is that you selected a meal that comes with dessert, and now you're allowed to choose exactly one of the following: cake or ice cream, and you're supposed to say what you want. But you know, or in this case means this one or that one or both. Okay, so drawing a skeleton, just that same thing, but just smaller and without all the letters. So if you know, if that one is set A and that one is set B, then would you please shade in A union B? So what needs to be shaded in? Right. So all of that stuff. So, you know, cake or ice cream or both. That's union. Any question about it? Definition? All right. Fine. So now to give an example, I could say something like the following. Please calculate, no, actually, as a first step, please plot 8 to infinity union 2 to 4. So plot that. So what's written here is the union of two intervals. This interval, union, that interval. Okay. The way that we're going to do this is the following. When we're taking two intervals, and you've got to do an algebraic operation like this one, union, or we're going to talk about another operation called intersection, but not yet. Here's how you do it. You say, all right, I'll make 2 copies of the reals. So here's a copy. Here's another copy. And then on this copy, I'm going to write that one. So this is going to be, I'm going to shade in 8 to infinity for that one. And then for this one, I'm going to shade in 2 to 4. And to make this work right, we've got 4 symbols, right? 1, 2, 3, 4. And we've got to plot them on these 2 lines in the correct left to right order. So concerning these 4 symbols, that one, that one, that one, and that one, 8, infinity, 2, and 4, which one is least? 2. So I'm going to plot it here-ish. Okay, then you can kind of like, you know, cross 2 off the list. So now concerning the symbols 8, infinity, and 4, which one is least? 4. So I'm going to plot it just a little bit to the, here-ish. And also on this one. The reason why I'm plotting these down here is they both came from here. So now concerning, we can cross 4 off the list. And then concerning these two symbols, 8 and infinity, which one is least? 8. So now I'm going to plot it up here because it's on that one. And why shouldn't I plot it like right there?
Because we're trying to make it relative to the other line as well.
Right. We want, wherever we plot the 8, it's not exactly, it doesn't need to be exactly somewhere, but it does need to be to the right of the 4. Okay, so something like this. Okay, now what I'm going to do is I'm going to color these ones. So like this, I'll color in red and say that all right, this is including the 8, so I'll fill it in, and then everything to the right. So all of this, all of that, and then I'll color in this bit with green. So what do I need to do here? Okay, very good. And then all the stuff between them. Right? So now, the answer to the question of what is the union is I'll make, one last copy of the reals, and I'll mark all those points. So 2, 4, and 8. And the answer to what's the union is find all the points that are colored red or colored green or both colors. So I could start over here and say, like, maybe that point right there is like 1. So is 1 colored red or green? No, so it's not shaded. And then, how about that? That might be like 3. That point might be 3. Should 3 be shaded? Yeah, because it's colored green. How about like this one? This is like maybe 7. Now you can't really see it. So that point right there is 7. Should we color it? No, because it's not colored green or red. So we want to color all of the points that have 1 color or 2 colors. And you can think of it like this. If I had a big flashlight up here and that coloring could cast a shadow, what would be the shadow? Well, it'd be that stuff and that stuff, right? 2 to 4. And then 8 and greater. So that's the union. Any question about that? So, that's the union there. So you could write, well, that's it. So 8 to infinity. Union, what was it? 2 to 4. That's what it looks like as a plot. So that's curious because, like, when I asked a question, like, what's 3 plus 5? Well, the answer was 8. So, in that sense, you can take the number 3 and the number 5 and you can add them, and, there's a more simple way to write it. 8. But if I say here's an interval and here's another interval, compute their union, well, there's no simpler way to write it. That's it. It doesn't simplify. It doesn't simplify because they're not touching. The result is not an interval. So how can I see that that's not an interval? What C word am I fishing for? Starts with C. It ends with contiguous. So you can see that it's 2 disconnected pieces, right? This is not a contiguous set, so this isn't an interval. Well, that's fine. But we don't really have time to do it yet, but we'll do it next time we meet. If I asked you to compute 2 intervals, the union of 2 intervals, and when you plotted them, the red one was like here-ish, and the green one was like here-ish, and we were doing the same thing, green points, red points, and then points in here are green and red, then the result, the shadow would be one big piece. So that would simplify, because the resulting shadow, if you like, is contiguous. interesting. So we'll talk about that next time, and intersection next time. That's all the time we have for today. So I hope you have a wonderful Wednesday. Please turn in the odd ones on the way out.